a silicon micro machine cavity and a quartz sealing. So it's a completely packaged device. In this work, we will see an open Otto chip, so it's not sealed, it does not have the quartz sealing, and we investigate the prospects of using this chip for pressure sensing. First, I will show you the Kretschmann configuration, which is commercially used for optical sensors, where in this case we have this infrared beam, and this can be a gold layer. So at some angle, specific angle, there is some coupling to a surface plasmon resonance effect along the Neto's field, and the sensing is done in this part, mainly here. So here's we can detect changes in this refractive index. So this is the Otto configuration that we are currently working on. As you can see now, the gold layer is on the other side, and this creates a channel that can be used for sensing, so we can have some gas or fluid in this part. We have again this infrared beam coming down here, and then at a specific angle there will be some coupling to the surface plasmon resonance effect. So the advantages of using an Otto chip. First, there's the addition layer does not affect the quality factor of the device. If we go back to the Kretschmann configuration, in order to deposit gold right here, normally chrome or titanium can be used as an addition layer, a seed layer. So in this case, in this configuration, the plasmon effect going here, there's a field inside this addition layer, and this degrades the quality factor. We can see in the Otto configuration, we use thick metal films, so there is no field inside the chrome layer, the addition layer. Another advantage of using the Otto configuration is that we can use opaque substrates like CMOS grade silicon, which will be here. So in this case, our electronics can be integrated with the sensor. And finally, as it will be shown in this work, there's a dependence of the SPR effect on the gap of this Otto chip. In this work, this is done to sense the pressure. So here I show the dependence of the SPR effect on the gap thickness. So you can see this is the coupling to the SPR effect for different gaps in the Otto chip, where this is where the sensing is done. So the optimal coupling with the highest quality factor is somewhere around here between these two values. This is in micrometers, so this distance here is between 2 and 2.5 micrometers for an optimal coupling. The fabrication of the chip is very simple. So it starts with a silicon wafer, and then a photoresist mask, and deep reactive ion etching is performed to define the cavity of the sensor. Then the photoresist is removed using liftoff, and then another second mask is placed right there in order to deposit chrome and then gold on top. Then again, liftoff is performed again to remove this part here. And finally, to have the input and output for the gas to the sensor head, an aluminum mask is placed on this side of the substrate, and then again deep reactive ion etching is performed to produce the input and output. This is the experimental setup. Here is the open Otto chip, so and the pressure can be varied by having some gas flowing from the inlet to outlet. So here we will have this laser source, which then passes through a polarizer to have a normal field incident here. Then it goes through a splitter, This is a reference photo detector, and then we can measure the reflectance here in this signal photo detector. The chip is placed inside a metal cell, which is here. It's sealed by this gasket. And there's a buffer layer that produces the initial pressure to the chip. And then the pressure can be varied by having a gas in and out of the structure. Here we can see the gap, which is this part here. So continuing with the experimental setup, here are some photographs. Here you can see the chip, the silicon chip. It has a buffer on top, which sets the initial pressure using these screws. And then through this inlet and outlet, the pressure can be varied, and the changes in the gap were detected for different pressures. So here we can see the results. As pressure varies, we can see the changes in the coupling effect of the SPR. So the pressure changes the gap in the chip. So this is the refractive index of the gold film we used, and we can see the change in the gap according to the different pressures. Here we can see the measured pressures and gap thicknesses, and this is the trend line. It's almost linear. So there's approximately a linear relationship between 0.3 and 1.3 bar, with the thickness gap is changing between 1.3 and 2.5 microns. So to conclude this talk, well, we demonstrated an open Otto chip. This open Otto chip has potential for applications like a pressure transducer. The results show that the gap is very sensitive to the pressure changes, and the working pressure range can be adapted by using different buffer materials. Thank you very much for your attention.
Thank you. Any questions or comments?
Yes, I have one question.
Yes, please.
When the incident angle changes, then what happens? In measurement.
Professor Fontana, can you address the question?
Sure. Could you put the picture there? The picture back there.
That's it.
Yeah. You measure the signal detector DS against the angle, and when there's a coupling with the wave, you have a resonant absorption. So you have a resonance curve. I think Ignacio can show the resonance curve there. And that resonance curve depends on the gap thickness. The amount of coupling of the input lights to the surface wave that gives that resonance curve depends on gap thickness. So that's what happens.
In the former page, almost the same question. So the incident angle is very sensitive. Very sensitive.
The what?
So can I show me the previous?
The previous.
About lately the incident more.
Back.
Please.
Back. There. Yes.
Okay, in here.
There.
So I think the sensitivity is 42 and 42.
Yeah. I mean the angular.
It is too sensitive.
The angular range is very small. Yeah. This is specifically this device. This reflectometer is an automated one. It can measure 0.01 degree resolution specifically. So it's very sensitive. I mean, you can measure it high sensitivity.
When I watched this graph, so that maybe there is some measurement error can be induced because this is instead the angle is too sensitive, in my opinion.
Yes.
Specialist is required.
Yeah, but you see that the non-linear regression fitting is very good.
Yes.
Okay, and you can measure those angles very, very precisely, absolutely, and relatively too. You know. Yeah.
Thank you. More question? Yes.
What is your application for? Because I'm not a specialist for this, so what would be useful?
Well, the first Otto chip devices that were demonstrated are thought for gas sensing. Yes, gas sensing. And in this case, well, we demonstrated that it can also be potentially used for pressure sensing.
Okay, thank you very much. This is the last paper of this session. The time is 35 ppm, so it's 6.5%. Efficiency harmonic